In the previous sessions, we came out with the expansions in terms of a series, but we actually didn't evaluate the series itself. So let's see how we can evaluate the series. Basically, what it means is that given a trigonometric expression, we were arriving at the series, right? Now here we are given a series and we have to come out with the expression which will help us in evaluating the series. Okay, so let's see. First what we look at is summation depending on geometric progression, and in this let's be more specific and say angles are going to be in arithmetic progression. Okay, so let n angles in AP be, say, alpha is the first angle, alpha plus beta is the second angle, alpha plus 2 beta is the third angle, and so on, so that the nth angle would be alpha plus n minus 1 beta. Now here remember, this we have already seen, arithmetic progressions and geometric progressions we have already seen during high school. Now what we are going to do is we will take up the sine series. So sine series of these angles will be sine alpha plus sine alpha plus beta plus sine alpha plus 2 beta, and on and on and on till the nth term. So that would be sine of alpha plus n minus 1 beta, right? And let's name it as S. So the cosine series will be what? So cosine series will be, let's say, C is equal to, so cos of alpha plus cos of alpha plus beta plus cos of alpha plus 2 beta, and on till we reach the nth term. So that would be uh, alpha plus n minus 1 beta. Okay, now what we are going to do is we are going to multiply s by I and add it to c. So we will have c plus is. So I'm sure you already got the hint where we are proceeding towards. We are proceeding towards cos theta plus I sine theta kind of expression. So c plus is would be cos alpha plus I sine alpha. Remember, we are adding both c and s after multiplying s by I. So we have taken this and we have multiplied this by I and added it. Plus, again same process, cos, and this time the bracket would be this, cos alpha plus beta plus I sine alpha plus beta, plus again cos alpha plus 2 beta plus I sine alpha plus 2 beta plus dot 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 dot, and the nth term would be cos of alpha plus n minus 1 beta plus I sine alpha plus n minus 1. Okay, now we have got this. Now what do we do? Remember the exponentiation form? So this becomes e to the power of I alpha plus this will become e to the power of alpha plus beta I. This will become e to the power of alpha plus beta 2 beta I plus e to the power of, if you follow the pattern, alpha plus 3 beta I, and on and on and on. And the nth term would be e to the power of alpha plus n minus 1 beta I. Every one of these terms contain e to the power of I alpha. Yes. So what we can do is take it out. E to the power of I alpha times 1 plus e to the power of I alpha is gone. So we are left with I beta plus I alpha is gone. E to the power of 2I beta plus e to the power of 3I beta, and on and on and on. So nth term would be e to the power of n minus 1 beta I. Okay. Now if you notice, this is a geometric series and the common ratio is e to the power of I beta. Now this series we know how to evaluate. So e to the power of I alpha times 1 minus e to the power of n I beta by 1 minus e to the power of I beta. Yes. Now, in what way can we manipulate this? Uh, let's do this. E to the power of I alpha 1 minus e to the power of n I beta by, and here e to the power of I beta by 2. So what happens if I take out that? Basically, the idea is in the denominator we should end up with some kind of a sine or a cos. So for that we require e to the power of I beta plus or minus e to the power of minus I beta. Here we have 1, here we have 1. E to the power of 1 I beta. So if we take out half, we will end up with e to the power of minus I beta by 2 minus e to the power of I beta by 2. If you open up this bracket, this 2 multiplies, it becomes e to the power of 0, which is 1. So these two will add up and become 2I beta by 2, which is I beta. Okay. Now, what else can we do? Okay, this would be, we'll take this up. So this becomes e to the power of I is common, alpha minus I beta by 2. Okay. 1 minus e to the power of n I beta divided by. Now here, if you have a minus sign here, uh, that minus sign should be there with a negative exponent, right? So let's reverse that. So let's say e to the power of I beta by 2 minus e to the power of minus I beta by 2, which means we have to take minus out and we can take it up. Okay. Now remember, sine is equal to e to the power of beta by 2 is equal to e to the power of I beta by 2 minus e to the power of minus I beta by 2 by 2i, right? Now this 2i we can take it here. So that means this will become minus e to the power of I alpha minus I beta by 2 times 1 minus e to the power of n I beta divided by 2i sine beta by 2. Now in the denominator we have I. So 1 by I is equal to, we can multiply I by I, we get I by minus 1, which is minus I. So which means this we can cancel it, and this minus will become plus and I will come up. So we'll end up with I e to the power of I. Let's multiply it off. What do we get? We get I e to the power of I alpha minus I beta by 2 minus I e to the power of I alpha minus beta by 2 plus n I beta by 2 sine beta by, yes, let's do this. Let's take I common out. Let's not keep repeating it. We get e to the power of I alpha minus, this I not required. No, this is, what am I doing? This is also not required because I is common taken out. So minus. See, we have to be very, very careful. So beta by 2 minus e to the power of I common alpha minus beta by 2 plus n beta by 2 sine beta by. Okay. Now let's convert this back into cos theta plus I sine theta, right? So I times, this can be written as cos alpha minus beta by 2 plus I sine alpha minus beta by minus. This again we can write it in this form. So cos alpha minus beta by 2 plus n beta plus I, no, because of that minus, this will also become minus I sine alpha minus beta by 2 plus n beta divided by 2 sine beta by 2. Okay, it is a tedious process, so we don't have a choice but to be patient. Now let's multiply off this I. So we get I cos alpha minus beta by 2. Now I times I square minus 1. So this becomes minus sine alpha minus beta by 2 minus I cos alpha minus beta by 2 plus n beta minus, again I into I square minus 1. So minus into minus plus sine alpha minus beta by 2 plus n beta by 2 sine beta by 2. Okay, so now we can split it into real and imaginary terms. So let's write this, sine of alpha minus beta by 2 plus n beta minus sine alpha minus beta by 2 by 2 sine beta by 2. Then we have plus I cos alpha minus beta by 2 minus, we can put it in a bracket, minus cos alpha minus beta by 2 plus n beta divided by 2 sine beta by 2. So this is nothing but C plus IS. So now let's equate real and imaginary parts. C is equal to sine alpha minus beta by 2 plus n beta minus sine alpha minus beta by 2 by 2 sine beta by 2. We have to think of an identity where something is equal to sine of a plus b minus sine of a minus b. So if we think about it, what we'll arrive at is 2 cos alpha minus beta by 2 plus n beta by 2 and sine n beta by divided by 2 sine beta by 2. Now just verify it. 2 cos a sine b is sine a plus b, a minus b. So let's see. Let's add up this first. When we add it, what happens? Alpha minus beta by 2 remains as it is, n beta by 2 plus n beta by 2. That gives us n beta, which is what we have here. Now for this, we subtract these two. We get alpha minus beta by 2 plus n beta by 2 minus n beta by 2. So we are left with alpha minus beta by 2. So this is correct. Now 2 and 2 gets cancelled and we are left with cos of alpha minus beta by 2 plus n beta by 2 sine n beta by 2 by sine beta by 2. Now here beta is common to two terms, so cos alpha plus n minus 1 beta by 2 sine n beta by 2 by sine beta by this alpha plus n minus 1 beta by 2 is what? Alpha is the first angle, beta is the, since the angles are in arithmetic progression, beta goes as beta plus 2 beta plus 3 beta for each angle. So this is the common difference. Okay, so let's see how further we can refine this. So let's write it as uh, 2 alpha plus n minus 1 beta by 2 sine n beta by 2 by sine beta by. Okay, now this 2 alpha, let's write it as alpha plus alpha. So this becomes the last term, this becomes the, or rather this is the first term and this is the nth, sorry, this is the first angle and this is the last angle. So which means this is going to be cos of first angle plus the last angle divided by 2. Remember this by 2 is for both. So times sine n beta by 2 by sine beta by. So this can be written as sine of n times the common difference by 2. And this can be written as common difference by 2. This is for what? This is for the cosine series. Now, similarly, S will be what? S is equal to cos of alpha minus beta by 2 minus cos alpha minus beta by 2 plus n beta divided by sine beta by 2 sine beta by 2. Okay, so now how do we simplify this? Again, just like we did for the previous one, this will be equal to 2 sine alpha minus beta by 2 plus n beta by 2 sine n beta by 2 divided by 2 sine beta by 2. Okay, so 2 and 2 cancel out and this becomes sine of alpha minus plus n minus 1 beta by 2 sine n beta by 2 by sine beta by, similar to the cosine series summation. So we can write this, or rather we can take it further. More simplification we can do is this beta by 2, let's, and alpha we can add it up, we can say 2 alpha plus n minus 1 beta by 2 sine n beta by 2 by sine beta by 2. Okay, and this 2 alpha can be written as alpha plus alpha. So this becomes the first angle, this becomes the last angle, nth angle. So which means this can be written as sine of the first angle plus last angle by 2. Yes, times the sine of n times the half of the difference. So beta is the common difference by 2 and the whole thing divided by sine of difference by 2. So what have we achieved? We have shown that S is what? S is sine alpha plus sine alpha plus beta plus sine alpha plus 2 beta plus and on till sine of alpha plus n minus 1 beta is equal to, instead of laboriously adding up all this, we can directly do sine of the first angle plus the last angle by 2 times sine of n difference by 2 by sine difference by 2. Similarly, the cosine series would be cos alpha plus beta plus cos alpha plus 2 beta plus and on till cos alpha plus n minus 1 beta. This would be equal to cos of alpha plus n minus 1 beta by 2 times sine of n beta by 2 by sine of beta by. Here also, let me not mix up the terminology I am using. Beta by. So whenever the angles are in AP in a series, we can use this to do the summation. In the next session, we will do a practice problem. That's it for now. Bye.